Welcome to AP Calculus, Applications of Derivatives, Lesson 5, Finding Extrema on an Interval. So, those extrema will come in the following forms. A relative maximum, a relative minimum, an absolute maximum, or absolute, not or, and absolute minimum. Okay, these will occur where we've already studied. These can occur at relative maxes or at endpoints. And absolute minimum, they can occur at endpoints or at minima, just depending on the circumstance. So what are we going to do? We're first going to find all the relative extrema, then evaluate endpoints to find absolute maximum and absolute minimum. Let's look at a picture to see. Okay, we have a relative maximum of 5 at x equals 2. We have a relative maximum of 4 at x equals 6. We have a relative minimum of 2 at x equals 4. We have an absolute maximum of 5 at x equals 2, and we have an absolute minimum of, that looks like 1.5 at x equals 8. Those are all the relative minimums and maximums, absolute minimum and maximum. Okay, moving right along. Okay, we have a relative minimum of 3 at x equals 5. We have an absolute maximum of 7 at x equals 2, and we have this relative maximum is also the absolute minimum. Okay. Now I think at this point I should point out to you that sometimes it's not relative minimums and maximums and absolute minimums and maximums. Sometimes, instead, some AP questions talk about local maximums, local minimums, and global max and mins. Okay, locals, that will just be all relative and endpoints. See, what we've done before, we've not looked at endpoints as being relative. Well, this still isn't relative, but the relative maximums and minimums plus the endpoints, those are where you're going to find all your locals and globals. Sorry, all your locals. And then the globals will just be like the absolutes. So if we're going to evaluate this one we're using this terminology, you're going to have a local maximum at x equal of 7 at x equals 2. You will have a local minimum of 3 at x equals 5, and then we will have another local maximum of 5 at x equals 8. We have a global maximum of 7 at x equals 2, and of course we have a global minimum of 3 at x equals 5. So just another way of looking at a graph or a function to find maximums and minimums. From now on, for the rest of this, I'm just going to do relatives and absolutes. Okay, sometimes you can't evaluate the endpoints because they are not defined. This would be on an open interval 2 to 8. In that case, we have one relative minimum at of 4 at x equals 5, and that is also the absolute minimum. So that relative minimum is also the absolute. Sometimes, alright, let's see here, we have a relative, not a relative, we have a relative minimum of 2 at x equals 6. Okay, because of this vertical asymptote and these approaching that, we will never find an absolute maximum, but that relative minimum is also the absolute maximum also, because it is the lowest point on that interval that it goes right here. That's also the absolute. Let's keep on moving forward. Okay. Sometimes we won't have a relative maximum. We won't have a relative minimum, because right there at the relative minimum it is undefined, but right there, no absolute. So no relative mins, no relative maxes. However, we do have an absolute maximum of 8 at x equals 4, and that's the only thing we can say out of that picture. Let's look at one more. We have a relative minimum of 1 at x equals 6. We have a relative maximum of 5 at x equals 4. Because this function goes down and approaches that but never gets there, and as well as this asymptote here, we're not going to have any absolute maxes or mins on that. Now let's see a couple of functions written but not graphed and see how well you do. Y equals 2x minus 3x to the 2/3 plus 4 on the closed interval -8, 8. So we need to find relative mins and relative maxes, and we also need to evaluate the endpoints. So I will let you find the relative mins and maxes. So go ahead and pause it right now to find those. Alright, I found the first derivative. I set that equal to 0 and solved and found x equals 1. I also noticed that y prime was undefined when x equals 0. So now I'm going to use my first derivative test to find my relative mins and relative maxes. So I'm going to let you pause it after we get this set up, and you go ahead and find out relative mins and relative maxes. Alright, as I've done that, you can see I put in a value -1 and got a positive value for y prime. I put in 1/8 because I needed a nice cube so that I could figure out the cube root. That ends up being negative, so we have a relative maximum of, we'll have to evaluate that, at x equals 0. We have a relative minimum of at x equals 1. So let's put in a 0 here. Oh, 0, 0, that would be a relative maximum of 4. And now let's put in a 1. 2 minus 3 plus 4, that would be a relative minimum of 3 at x equals 1. Let's evaluate the endpoints. Haha! Now you get it why we've got 8s here. So let's see here. Endpoint of -8. Let's find that y value. -16. Subtract 3 times -2 squared plus 4. -16 plus 12 plus 4, 0. And we have another endpoint at 8. What's the y value? Put that back into the original. 16 minus, alright, 3 times 2 squared plus 4. So 18 minus 12 is 6. So this will be the absolute max, and this will be the absolute, wow, no, this will be the absolute minimum, sorry about that. And 8.6 will be the absolute maximum. Alright. And then I have a trig one for you that we'll have to do in class because I've got 24 seconds. So make sure I show you the trig example in class. This will conclude Extrema on an interval, Lesson 5, AP Calc.